Okay, good morning. Welcome to our first lesson in Chapter 11. We're skipping Chapter 10. We're going to move on to Chapter 11, give you some exposure to some principles of circles. And so 11.1 talks about different lines that intersect circles. And again, a lot of this might seem difficult because it's new to you, but you'll see hopefully through the video or studying it that it's really not that complicated what you're actually calculating and figuring out. But regardless of that, let's dive right in. We've got several definitions here and then two questions. You'll see most of the definitions we can illustrate with a single drawing, and I'll do that in a moment. So we have circles. Okay, I'm going to draw just a beautiful circle here. I'm sure perfect in every way, not quite. Okay, and so we want to differentiate between the different lines that can intersect a circle and what, again, the special relationships that those lines can oftentimes have. So first of all, a chord. Okay, not a musical chord, but a geometry chord. And so a chord is any line that intersects, that has endpoints. I'm sorry, any line that has endpoints along a circle. So if I have point A and point B here, this here is a chord. So a line that has endpoints. That's the key word you'll see in comparing it with a secant line. Endpoints on a circle. Okay, so A and B would be the endpoints of that line. They're on the circle, so that is chord AB. I could draw lots of chords, but I don't want to fill this up. That's in comparison then to a secant line. And a secant line is a line that intersects a circle in 2 points. And so there's, I'm going to say the key point, intersects a circle at 2 points. The 2 is also important, as you'll see in a second. So like a chord, except it actually passes through the line. So if I draw this guy here, this is could be our secant line. All right. Now, intersect. So a chord has to have endpoints. So a chord is a specific type of secant line that stops on the endpoints, whereas a secant line, as long as it intersects. So the kind of a key thing here is that a chord can be a secant line, but a secant line cannot be a chord. So because a chord has to have its endpoints, whereas a secant line doesn't have endpoints, it just has to intersect. So both of these lines intersect. So both of these lines are technically secant lines, whereas only AB is a chord. So keep that in mind. That's one of the first differentiations between if it has endpoints or intersects. So all chords can also be secant lines. We'll go with that. All right. Then we have a third type of line. That is a tangent. And so that's a line that intersects a circle at how many points? Well, not at 3. That's impossible. Not at 0. That's pointless. But 1. At 1 point. To be tangent to something is to hit it at 1 point. So a tangent line to this circle would look something like this. And again, I'm not quite drawing it perfectly. But if my circle was perfect and my line was perfect, I would see it actually only hits at 1 perfect point. And so that would be a tangent line. So a tangent line has to go right along the outside of a circle, and it's only going to hit in 1 point, whereas any other line that's actually going to hit the circle will have to hit it twice, passing through the circle 2 times. And then point of tangency is simply a point, I'm going to write it down here, a point on a tangent line. Okay, so like this guy right here, C, that's a point of tangency. This is right out of the book, so. Okay, point of tangency. So all 4 of these are 3 types of lines, and then one. We're just building our vocabulary to be able to talk about circles through the next couple of sections. Concentric circles. Concentric circles are like what you might see on a dartboard or a framed circle, and that is circles with the same center. I'm just going to keep it simple. Alrighty, so concentric circles, if I have circle, there's my center, and I draw 1, and 2. That's where we get concentric circles. And I could keep drawing that, again, like a dartboard. But because the center is the same, they are concentric. Tangent, again, meaning hitting only at one point. Tangent circles are circles that intersect at one point. So these could look, as you see in the book, two different ways. Again, something like this and this, where that is a tangent, not a line of tangent, but those are tangent circles because they're touching only at one point. Or you could have one could be inside of the other. Drew something like that. Again, imagining that's perfect and they only touch at one point. Both of those would be examples of internally and externally tangent circles. Okay? So remember that word tangent, hitting at only one point. Alrighty. Questions. Two questions. They're kind of the theorems, basically, from this chapter, but I just made the questions to kind of help clarify them. And that is, better wake up my computer to read the question correctly. Number one, if a line is tangent to a circle, then how is it oriented towards the radius? Okay, so if you have a circle and you have a line that is tangent to it, how is this line oriented to the radius? Now, that's not my most perfectly worded question, but it's just an excuse to point this out. That whenever a line towards the center of the circle is what it should say. Whenever a line is tangent, that line where it hits the point of tangency will always form a perpendicular line. I'm going to do this in black. Will always form a perpendicular line to the radius or to the center. So that anytime you draw a tangent line, you can go back up here. Here's my tangent line. That point of tangency, if I connect that with the center of the circle, you will always form a right angle or a perpendicular angle. Okay, so the answer, so a tangent line always forms a perpendicular line between the point of tangency and the center of the circle. Okay. So whenever you see a tangent line, you can know, and this will come up because you're going to have to solve for right triangles. Like if I connect this, and all of a sudden I've got a right triangle, you can know that this always forms a right angle. And if again, I could draw the same thing over here, and if I find my point of tangency and I connect it to the center, I have a right angle. So those always form right angles. Okay. The second question: if two segments are tangent to a circle and extend to the same point, what is true about them? Okay, again, let me just show you what this is describing. So now I have, say I pick a point out here, and I connect this point, and I make it tangent to the circle, so it hits it in one spot, and from that same point, I extend it and hit tangent to the circle. Notice there's no other possibilities. To do this point and be tangent, I have to draw that line. And this point here, to be tangent, I have to draw to that line. The point is that from that point of tangency, here and here, I form two congruent lines. That the distance between that external point and the point of tangency is always congruent. That this distance here is always the same as this distance. So if this is 7, this must be 7. If this is 20, this is 20. And you'll see on the whole classwork, you'll solve some equations knowing that these two distances have to be equal. And again, I could draw any other scenario, and again, pick some arbitrary outside point. If I connect that point with just the outside of the circle, and I form it this distance here, I'm sorry, I should make the point. This point, the distance here and here will always be congruent. Okay? And so you're going to see that come into play as you solve different types of equations and answer certain questions in this chapter or this lesson and future lessons. Okay? So tangent lines form perpendicular lines with the center, and if they connect to the same exterior point, they're going to form congruent distances. Okay, there will be a couple questions on the classwork if you want help, but good luck and reach out if you have any questions.